Ultra Chill.
Hi guys, welcome to Ultra Chill. This is episode number 6. Today we have something a bit different with our first tech focus. I'm excited to bring on Romain Gilles to talk about Ultra's data architecture, how it organizes that data, and what we use it for. We want to give you all a sense of how we're preparing everything to unlock a data-centric enterprise scale operation. Hi Roman, welcome.
Thank you, Rami. Pleased to join this conversation, and it's ultra chill. My last experience in this area, my job just before, I was working for finance industry in the finance industry for software development in something like massive parallel processing to produce based on the data of the of the finance, produce indicators and help the traders to take decisions.
Well, I guess
And
you're kind of still working in finance, right? I mean, let's be
yeah,
honest.
yeah. Because in Ultra we have this part of the finance also because we are running our own money, and which is something really important for us to follow what happens. We'll talk about the Oracle later, I suppose, and that's part also of the financial facet of the Ultra
Okay.
ecosystem. The purpose of my team is to leverage and make the data available for everybody in the enterprise, and that goes from the back office system to the executive team, and also for the end users. Let's say if you want to know the trends of your NFT, you may want to see these trends, and this is data by himself. So you want to know what is the current value or the derivative value of the US exchange rate. That's part of the data we are collecting and leveraging on the top of it to extrapolate new values for end user, for executive, for backend system. Let's say, for example, if you want to have suggestion, we can, or download rates, or uh, sales rates, all those things are also part of what we are trying to improve and make the most available and most easy to access to everybody in the company.
Let's talk about what data actually is.
We are speaking,
Sure.
we exchanging data. You, by the message I send you, you build your own vision of the world. And as you are not French guy, I'm a French guy, we have different concept, and that's based on the data we receive every time. So in fact, when you click on a button, when you buy something, when you discuss with somebody, this all those things are data which are really can provide more added value.
It makes sense to me because I kind of understand how you guys have built the architecture. Maybe you want to take a step back and give a broader explanation of what event-based architecture actually is.
Event-based architecture is something you already, in fact, use. So as I say, we are exchanging message. There are events. Your browser is an event-based system. Your most of the UI application are event-based because you click, it's an event. Uh,
Sure.
you you switch a tab, it's an event. And the UI developer are quite used to use events system. Um, and what it means something reactive. You do not ask, you receive, and you react on what you receive. And that's change. It's the paradigm shift. We were discussing between the different teams, the backend, the DevOps, and the data team about a use case. We want to make sure that the sign up process operate correctly, and we were
Sure.
struggling. Okay, we need metrics for that. Let's say, did somebody receive the email? Did somebody receive the SMS? Yes. How can we do that? One option is to say, well, just put the metrics in the authentication server. But unfortunately, we are not implementing our authentication server. It's a good paradigm. Never implement security yourself. So rely
Right.
on something like it's commonly
Of
used
course.
because it's dangerous. And
Well,
therefore,
it's stuff that's been battle tested, and in general,
yeah,
we prefer to
exactly,
use stuff that's
exactly,
been battle
exactly.
tested,
So,
right?
okay, but so the backend team say, okay, but we cannot add those metrics. They are not part of the default metrics provided by this tool, and we cannot hack it, obviously, and fortunately. And so, but we send events. We send events when an email is approved and successfully received, and we send events when an SMS is successfully received. Okay, how can we do? Well, we just listen those events and we build metrics on the top. And then we can build our alerting system on the top. So without modifying, and even this team that is responsible for the authentication, you have the information, you make the information accessible, and then you can build on the top more or less in parallel, but without, it's in oriented programming principle, they call open close principle. Open to extension, close to modification. In this case, we don't have to modify an existing system, and we don't want to modify it. It's not our business. We
Right.
want to extend feature on the top of that.
What we're actually talking about here is something which has never really been built before. What we're talking about is something which is necessary for the end goal of Ultra, the business goals, right? So within Ultra, we have a system which is built of a pretty complex set of backend services. We have the blockchain, which acts as its own fully integrated system, right?
Mhm.
And then we have the front end services and the client, which consume all of those pieces, right? One of the things that we were talking about in preparation for this podcast was how important it is to have cohesion between all of those different pieces. So the Oracle, the way that it works is you have data which is fed into the Oracle, and on chain it's doing computation so that it can push a final derivative price to the table that exists on chain, which other smart contracts can have access to. Okay. Now, for our own internal uses, we have a supervision service which monitors the actions that are happening for the Oracle to make sure that everything is done correctly, right? What's important here is to understand that the blockchain acts independently and the architecture for the event services acts independently, and the secondary can be used to ensure that the primary is functioning correctly, right?
Yeah,
So I think what's conceptually interesting here, that I think that we should be talking about is um, how what Ultra is building is so unique and so wonderfully complex that it requires. It's beautiful, like really, like what you guys have been building, beautiful stuff.
what I
And
like is the wonderful and complex. It's yeah, it's
well,
nice.
wonderfully complex. That's what
Yeah,
we're
yeah,
here for, right?
yeah, yeah, exactly.
So um, there's many pieces of the Ultra platform, like not just the blockchain, but the platform as a whole, which they fit together like highly complicated puzzle pieces so that they can complement each other to fulfill the end business goals. And I think that from the outside, people don't really understand, for example, why the project takes as long as it takes. They don't really understand the complexity that's involved. And especially when you're talking about discrete systems like an open network, like our blockchain is. In a second, I'll have you explain like what the consequences of that are, because I think that those
Mm,
are interesting. We talked about
mm,
that briefly before. When we're talking about these discrete pieces and having the opportunity to integrate them, it requires kind of not novel but very modern approaches. And the event-based architecture that you guys have been building really is the solution for that. Yeah.
yeah. So let's um the Oracle supervision is one thing, but you can imagine, as you say, um, I say just before the blockchain is a closed ecosystem, but it's true for the computation part. But in terms of usage, pattern, it's totally open.
Right.
I mean that's the main difference. First, it's, let's say, our blockchain, not exactly because we are not rolling the blockchain ourselves, but it's something that everybody can access outside Ultra. Our backend components are one piece. It's you that's signing the transaction. It's not the backend system. Our backend system is not involved in that. You need
Yeah, yeah.
to react on that. And the way you react on that is based on events. You sign, we receive an event that you have signed this transaction. But let's imagine, and I hope it will be the future of our blockchain. Let's imagine that uh, you have an NFT, and this NFT is not managed by Ultra. It's managed by somebody that has crazy idea around how to manage NFT, better idea than us. I hope no, but why not? That's the beauty of the open system. And this NFT, you sell it on this marketplace, which is not ours. How do we know that? How can we react and make it available? Because, and maybe this, the guy that will buy this NFT is not on this marketplace but on our marketplace, on our different marketplace, an
Right.
ecosystem of marketplace, auction place, whatever you want. And how they react, how they interact, they can pull, as I say all the time, what happens on this specific table for this specific NFT. But at the end, it's really way better to say, hey, you know what? I just heard about this NFT is on sale. Are you interested in it?
Because of the nature of a blockchain, it's an open network that
Yeah.
has smart contracts running on it, applications that run on the network, right? Which right now Ultra uses for our own purposes. But in principle, anyone can use those smart contracts for their own purposes. So we're building our own NFT marketplace, right? But
Yeah.
it's based on the NFT standard, which has been deployed to the blockchain. And in principle, any other party can build their own marketplace that mints its own tokens and has access to the tokens which have already been minted that exist on the NFT marketplace. So you can have a situation where an NFT is minted on somebody else's marketplace, but it can have a continued life on our marketplace,
Yeah.
right? So you have to have a system which talks between that marketplace and our marketplace. And you don't want to have a constant polling where you go to the blockchain because the blockchain is slow and it's expensive to use. You don't want to have a system where you have to go and check the blockchain every second or every 5 seconds. You want to have a system which tells you, hey, something is new, something has happened on the blockchain. Why don't you take a look,
Yeah.
right?
Exactly. And even in terms of user interaction, can you imagine having something where you wait every 10 seconds to have a bunch of
Oh, it's terrible.
new stuff? But with the openness of the blockchain, then you need to think differently. Somebody else will do it, but maybe somebody on our marketplace want to buy it. Taylor will will be happy because it goes faster, because he has an exposure on the capability to sell something really without any comparison. Is not close to one marketplace, is open to everything because the blockchain is open to everybody. So here, if the marketplace that are built on the top of the blockchain or auction place, let's say, if there is a capability of breaking the boundaries and making available for everybody, and it will be exactly the same concept for the games. And when we'll go into the games dimension and play with the NFT made on the top of the games assets, then again, you your game creates something, mint some NFT, and they will be immediately available somewhere else, maybe where you never think about it. But
Well, it's not. We're not
that's
just talking about NFTs here. Just to be clear, like what we're talking about, everything that happens in a block, which is all transactions. That could be account creation. That could be transfers. That could be NFTs. That could be like anything. And the truth is, that's something that we leverage extensively within Ultra because of the event-based architecture that you guys have provided us.
If we go a little bit more about the domain, the data domain area, it's called more or less, it's a buzzword right now, but it's called data mesh. In fact, you
Sure.
put the ownership of the data not to a middleman team, but to the source of the data, and you make them accountable for the quality of the data they produce. As we make accountable the blockchain for the quality of the data it produces, but by definition, it's how it has been designed at the day zero. So in fact, is here what we did is how we can, based on the quality of this data, extract it and make it available in something like real time. So that's what we were working on, to integrate it into our data mesh, and we do it for every external source of information, which are, for example, the blockchain. Even if it's us that develop this blockchain, for us, we look at it as an external source of data to make sure that it's consistent into our data mesh system.
The blockchain's finality, because we're running EOSIO technology, is really super fast. When you guys have an event which is registered by the data team's architecture, how fast is it actually available to everybody else?
So if we took the different step, a block goes through in the iOS system, and let's say we don't have a fork or something like that,
Sure.
um, something like, I think it's less than a second. It's
That's
less than
super
a second.
fast.
Yeah, because as soon as it goes into a block, it's planning for next block to be mint. We have the this information.
And
So it's called,
that event is already pushed back out to
yeah,
whatever reactive platforms are using it, right?
yeah, exactly. So in terms of, as soon as the block, as soon as the transaction reach a block, we have this in order of milliseconds, something like 50 to 100 milliseconds, something like that.
Wow. And just to be clear, the way that it used to be done was that it would be registered on a database, and you would send a manual query or an automatic query to that database to request the data, and then you would receive the data, and then you would parse the data on the client side, right? Which would take significantly longer.
On our side, we don't want to, on, let's say, on the backend and on the data part, we don't want to rebuild yet another blockchain.
Right.
Is not an easy thing to do, and you know why. You know
I
why
do.
for
I
that.
really do.
Yeah, yeah. uh, but what we want is to have a point of view on what happens on the blockchain. I'm interested in the user account creation. I'm interested in the sales of the unique. I'm interested into the buy of the unique. So I'm more interested into actions. I want to, for example, build the inventory of a user. Like you have in
Sure.
Twitter,
Sure.
but to that, I'm interested. I don't care about account creation. I care about sales, sales by mint dedicated to
Price.
my account. And to do that on the NFT smart contract, it's not an easy query. You have to find the table of the smart contract. You have to take its my scope. You have to build this query and say, I want the data structure of this table. And every time you go, you stress the ecosystem to do that. So you can build some cache on the top of that by taking really what you want to see. And so, okay, it's maybe a lot of data replicated, but it's really efficient for what exactly you want to see. It's your inventory. We build a view of your inventory, exactly what you want.
Well, I think what's interesting there that you kind of skipped over is that there's some information which is not available on the blockchain, right? So you have, when you go to the blockchain, you're actually only accessing the current state of the blockchain. You don't
Mhm.
have access to historical data, right? So if you're looking for previous transactional history that doesn't exist on the blockchain in the way that you or I would, conceptually expect it to. You actually have to go back block by block by block
Mm.
and then compare what there was to what there is and then make a history manually. And if anybody's used a blockchain, they're not super fast. So you don't want to do things that way. So you have to kind of like have something which is accessible and is super fast and is organized according to what you would expect it to be, right?
Yeah, exactly. Yeah, that's a good point. That's also one of the key part of the event. It's
Right.
when you store events and not states. It's like when I talk about you with you about that. It's like your bank account. While you're
Sure.
looking into your bank account, it's the balance. But that's partially true. If you want to know where you spend your money, then you start to look at the history, so the transactions.
I guess also from a perspective of scaling, um, and that's really what we're talking about when we talk about the Ultra project, because the expectation is for the project to scale to millions or tens of millions of users. And that means it has to be as efficient, it has to be as accessible, and it has to be as ready as possible. And the work that you and your team have been doing is in preparation for that. You want to talk a little bit about maybe what that means and how the event-based architecture affects scaling?
Um, that's really technical, but when you talk about mm, parallel computing or massive parallel computing or all those things, or you know, really efficient computing, you never talk about synchronous call. You always talk about asynchronous operation. So, for example, I used to work I'm still working in the Java landscape, let's say, and for example, we struggle a lot, and there was a lot of micro framework developed to optimize computation because Java is not the best language to do really efficient code. So, and when you come to see those codes, those micro framework, they are all based on queuing of events. You fool your CPU with one kind of event, it iterate over that. It doesn't have to pull something to get. It just goes there. You feed your CPU with those structural information and it iterate over it, and is never good do context switch or something like that. You want to make it the most efficient you can for a dedicated job. Can you give me this information? Can you give me? No. You receive the information. You just focus on computing on this information. And if you do it, you say, okay, now I need one guys because I receive something like 1,000 events per second. Okay, what about a million events per second? Well, okay, I like load balancing. You just put multiple queues and consume those queues in parallel. If there are, um, I think it's the universal law of queuing or parallelism. I will retrieve the name, but the most the most your job is self content, the most you are efficient, and it reduces the contentions. If they are really this is the only way to do parallelism, maximum parallelism, and that's really
I
important.
guess I guess the most simple metaphor that I can think of is like if you work in a kitchen, you don't want to have one guy that is cutting some onions and then going and working on a stew and then making a cake and then serving it to the people that are waiting for their food. You want to have one guy that cuts onions. You want to have one guy that's making the stew. One guy, and then you have one guy which is going afterwards and retrieving everything that needs to be retrieved, and then another guy which is bringing it out to the people that are waiting for their food. So it's the most efficient, it's the most accessible, and sometimes you'll have people that aren't working right now, but when they are working, they're going to be doing it in the most efficient way possible.
Yeah, and also there is job stealing. This cool. So you don't do that, you have no more to do. But what about doing something else? The event architecture goes in that direction, more or less, not exactly, but that's the idea. Is really to maximize our parallelism capability. Now, if we look at the data part, because here we were talking about mostly how the events can be consumed and parallelized in terms of backend consumption. But for the data part, based on those events, we can, as we say, we can see the history part, we can build a snapshot, we can automatically integrate them because they are described, they have some information inside those events that allow us to route them, describe them, join them. And that's something we are right now really working on, that is to really put the maximum value on those information to, for example, for even identify personal information. You know, we want to know where the personal information are. Based on those events and their description, we can identify that, we can track it, we can know where it goes, and we can say, okay, now you want to remove your information, okay, it goes there, it goes there, it goes there, so please, those components, please remove it.
And as we grow and as the complexity of the project, increases tenfold or a hundredfold, then those kinds of requirements become absolutely necessary.
Yeah, exactly.
Yeah.
As I say, it can be used for personal information, it can be used to how we collaborate, it can be used to optimize our deployment, it can be used in plenty of area, but we are not yet there, but we will go, I'm pretty sure.
I'm pretty sure too. All right. Roman, that's been a really interesting discussion. I really appreciated your time. Thanks a lot for coming on board. Thanks again to all the Ultra fans out there. We're always excited to bringing you more news, insider info, and in-depth details of what we're building, why we're building it, and how we believe that it will shape the future of gaming and digital assets. To keep up to date with Ultra content, make sure to subscribe and like this video. See you next time and keep it ultra chill. Thanks again, Roman.
Thank you, bye bye.
Ultra